Hi and welcome to my shop. It's March 2nd. Oh my gosh. And it's been a few days since I worked on this radio. I did a couple other smaller projects. And now I get back to this radio. What to do about it next? Well, I think the first thing I've got to do is I've got to clean the band switch, because clearly that's part of the picture here. Shame on me for not doing it sooner. But indications were, to me, that the switch was actually not a potential source of trouble. It's just this little switch here. And we're going to blast it with some cleaner here. Good. Now my room is full of this explosive vapor. So I'm going to leave here for a little bit and let the gas dissipate. I think what we're going to be doing on this today is alignment. Okay, I think taking a look at this schematic is a good place to start. So I would want to be able to measure the ABC voltage, which is the rectified output of the IF stage here. And this particular coil is the one that's open, and I've put a resistor in here across this point. And then I have a capacitor coming over here to feed the signal. Previously, up until recently, I had originally installed that capacitor down here, up to here. The radio worked, but I'm sure it would work better if I have the capacitor going from here to here. That was an error on my part initially. So where to get the DC voltage I'm looking for, the AVC, look, I got it written right there. Well, it can be picked off on this line here, anywhere on this line. This used to go down to the switch and come back up. Now you can think of this radio as just having a connection straight across here. So that brings me to this resistor, a 33K resistor, attached to the top of the volume control. Bottom of this coil, top of this coil, if I can get at it, I don't want to do it there, or the correct end of this 4.7 megohm resistor. They're all kind of the same place. Top of the 33 is pretty easy to find, I think. The non-volume control end of it. So we'll hook up a DC meter there. And the stronger signal that comes through the radio will produce a greater DC here. In some radios, in some very simple radios, that DC is just thrown away and ignored. But most radios use the DC that develops here, the direct current, to control the gain of some of the earlier tubes. AVC voltage, automatic volume control voltage. That's what we want to measure. Now we need to feed in a signal to do alignment. I don't have the alignment instructions here offhand. I'm going to have to find them. Well, I could wing this one probably. So we can start by feeding in a 455. Is that the right frequency? Do they have it written anywhere? I thought I saw it written somewhere. 455. I don't see it now. We'll assume it's 455. That's a pretty good assumption. And we'll make sure the IF is tuned properly all the way through, including this secondary transformer here. And we'll see if we can get some improvements just by doing that. So to feed in the AVC, the IF signal frequency, we want it to go into this grid here, grid number 3. So we could even feed it right into the antenna and try to ram it through, which is the easiest thing to do. Why don't we start with that? We'll try to ram it through, and as long as we get something out here, we should be okay. That sounds like a plan. Okay, I'm going to do that. Okay, first thing I want to do is get the radio receiving a kind of regular signal. It's going to be 1300 or so, and we'll find out if the ADC meter I have set up just over here is going to respond. Got the connections made as I described. We have a moderate signal coming into the radio. That's full volume there. Wow. If when I had an antenna connected to this, it was plenty loud. Let's just check which band I'm on. Definitely on the AM band. So I guess the deal is I just don't have an antenna connected, so that's why the radio is quiet. So there's the signal. Now, what we want to see is a pretty good jump on this meter. So I'm going to set it to 15 volts, full scale. We're going to tune through that. It's just a little movement, not too much. Well, I am going to do an alignment, so that, this could be the reason why it's low. It's poorly aligned. Okay. Just for fun, let's go down here and try again. So this would be somewhere. Check the calibration on my signal generator here. Yeah. Way too high. Way too high. Okay, now we're more calibrated. What's this sound like now? Well, I don't think that's too bad for the signal strength coming in. It should be a little bit clearer. What's kind of this is really low. So put it on 5 volts so we can see the rise better. Oh, it's almost nothing. Because there's a DC voltage sitting there to begin with. The volume up full, so that kind of tells the story. Very weak signal coming through the radio, being boosted a lot by the audio circuits. If I put this in a normal volume setting, let's say like that, now I'll jack up the input on the signal generator. There, we're getting a little more normal deal here now. But the signal I've got going into the radio is very, very strong. Sounds a little buzzy, but it could be because of the ratty speaker up here that it just doesn't sound quite as pure as you'd want it. Okay, but that's good. That's a good starting point. So we know the meter's working. We know it's reading the ABC. So we'll set this to 455 and see what comes out of the radio. Oh my gosh, it's a mile off. 420. Well, isn't that a funny coincidence? Because I got 420 sitting on this clock here. 420, that's an interesting number. I'm Canadian, 420 might mean a little more to Canadians than it does to other people in the world. Some other people. Okay, so we don't want it at 420, we want it at 455. That's a long ways away. So I need to get some tools ready so we can start making adjustments and we'll start tuning. That's a good sign, actually. Okay, we need to make a couple of checks here. We don't actually have to listen to this. We just keep it on very low. First one is I don't have an IF can over top of that IF transformer. What happens if I stick this can on there? I'm going to need to ground it. I don't think holding it is a good idea. Just holding it as a Well, that's where that screw went. Okay. We'll just clip this on the ground here somewhere. I'm going to slide this on as much as I can. We're going to watch the AVC meter and see if it reacts to it. So this may cause retuning. Now, I don't want to short into anything, but who knows what's going to happen. So it's already moving. So we look at this, it's at 9.5. Yeah! Hey, good thing I had a ground wire on this. Okay, so that's a little dangerous doing that, as you can tell. But wow, did it ever make a difference? It made a big difference. Okay, let me remove that now. Set that aside. Now the primary coil is this upper one here. It should make no difference. It makes a little difference. It's the lower coil. Oh my gosh, that makes no difference. I've left the tails on this resistor here. So this is the bypass resistor, and that's the capacitor. It's associated with it, and here's the wire. It's definitely coming here to this coil. The other wire is going over here for sure. Well, that's odd, isn't it? This is the coil that is open circuited, and this coil is not. Okay, well, can't do it. Okay, anyway. Now there's a slug here that's sliding in and out of this coil, and there's another slug, alter from the bottom, sliding in and out of this coil. The one at the top here is unattached to anything. I can just pull it right out. I'm going to watch this meter again. What happens if I move this slug around? Oh! Wow, this is not adding up. I didn't expect anything to happen there. Well, think for a minute now. That's what I'm doing. I'm thinking for a minute. This is supposedly open circuited according to my earlier tests. Unless the slug is influencing this lower coil. Is that it? I don't think so, because then it would behave differently. It would go up all the way till it hit the other coil, or down down, but it doesn't. Oh my gosh, the whole thing is moving around. Okay, so the whole coil form is loose. Alignment. Oh, my phone's ringing. Okay, that was a nonsense phone call. Well, there's a lot of issues with this. So what I'm trying to do right now is find out if alignment is the cause of the weakness of the radio. I'm not trying to align the radio permanently. So what we should do is carry on, peak all this stuff. Maybe more curious things are going to happen. Let's see if I can do the lower coil. Now, this is not well supported here. I'm going to put my finger on that too. Okay, now again, I can only move this slug very slowly, but let's see what happens on the meter. Going down, going up, going up, going way up. Careful, going down. So that's a better spot. Now, what about the one at the top here? Oh, I don't like using heavy, like large tools on this. The tool may have an effect. Peak that maybe up. Get out of there. Oh, the whole coil's moving too. Okay, I don't know what I did there. You have to use these little guys. Okay, oh, jeepers. There. Hold the coil. Okay, I may have my arm in the way. Sorry about that, but... Okay. So that thing is peaked as much as I can. Now, what about the other one? This is up pretty high. No, that's right on the money. And maybe I did this earlier. This one down here, I was hoping it would be way out. This one's sunk in quite a ways. Oh, I think it's right near the limit. Uh-oh. It's been turned all the way in. It has been turned all the way in, so I can't get at it with this recessed tool I'm using. I have to try with this one here. This one, the blade sticks out a bit on. Oh my gosh, there, I got it. Let's first back it out right away. What's going on the meter? The meter's going the wrong way. This feels like it's jamming up. Could it be, you know, a mutual thing? I'm going to put this in a more normal position. Let's switch to this one now. There. Okay, watching the meter. Just going down, down, down. Yeah, this is a more normal position. So can we compensate back with this one? I don't think it works this way, but let's try. No, that's as much as we get. So that the IF transformer being way off suggests the value of the capacitor in the can here is off also. And the range is off. I can't get it all the way. So that means this may, even if I crank this all the way in where it was, there's no peak appearing. So for all I know, if I could, I'd crank it even further. We can't. Okay. Wait a minute. How come it's going up now? How come it's going up? I'm cranking it out. Well, okay, that's a better thing. Okay, that's better. I'll try the top one again. Is there two? Sometimes there's two spots. Because, you know, there's a coil, right? Oh, I left this on. Let's say this is the coil. And then you've got the slug. Okay, so my thumbnail is the slug, right? And you start here. It's the same as being here. So I don't have any explanation. This didn't go anywhere. One peak and out again. What am I thinking of that as? You know, maybe it's the RF adjustments that have that can have two peaks in them. Well, I guess you could. If this is the same as this, then yeah, you would get, and if this was where the peak occurred, you'd get up, down. So you'd have two peaks, so you have a choice of whether to put the slug here or here. Part of the deal, I think, is if you put the slug at one end, it could be closer to the other coil. And so it starts to influence the other coil. So you want these things coming in from the ends. You don't want them in towards the middle. As a mutual effect, I think. You can see there's quite a distance here, but still. If the slugs were tuning properly, let's say in this area, and likewise down here in this area, but instead I'd move the slugs up to here, and the other slug to here. Now each slug is getting closer to the other coil. The actual carbon part, ooh, don't do that. The actual carbon part might be kind of in the middle here. And each slug starts affecting the other. I think that's the concern. Okay, so what did I do? So I was cranking this way down, hoping for another peak to come. There it comes. But you know what? So I think exactly what I just described is happening. Now, this is no good because it's going to disappear. It's going to fall in. So we're going to go back to the other one. And you know, I'm moving the slug up, I'm moving it away, so it's going through the coil and coming out the other end. Where have we gotten now with this? The only way to really know to hook up a radio, like hook up the antenna and listen, in fact. But I think the IF is now tuned. Oh my gosh, look what I've done. I've tuned it to 420. 420. Important time of day. Okay. Okay, that was a waste. Not really. Let's take this up to where it should be. And in fact, there's a good chance the radio will really come to life as I do that. Let's see. So we're going to dial up a higher frequency. Turn up the power here so we can still hear it. And go way up until I can barely hear it. Of course, that's because the volume's turned down. Let's turn the volume up. Let's go up higher. Okay, now we'll move all the slugs in favor of this new position. Can I make it all the way to 455? We're at 446 right now. I can. Okay, great. So I can still hear it. That's really important because now I know which way is better. So we'll start with the easy one now. Where'd it go? Got quieter. No, I turned the volume up. That's why it's louder. Oops, let's turn it down. Okay, do the bottom slug down here. Here we go. Ah! Keep falling out. Okay, more careful. Don't make it fall. Look at this. Look at this. Oh, it fell out again. Look what's happening. Some pretty good volume. Now I got a whopper of a signal coming in. I'm going to knock it back. Some more. It's in the very strong normal range. I'll double check this one again. Now it's out where you would expect it to be. Yeah, right on. Okay. We'll do this one. It's fine where it is. Now to the broken guy. Okay, doing the bottom. Oh, was I doing the bottom? Did I? No. For a minute there I thought I was doing the anyway, never mind. For a minute there I thought I was confused, but it turned out no, I'm just confused. Just does not want to go in because I got stuff in the way. Okay, watching the meter now. Ah! Don't slip out. So we're getting a huge gain doing this. That's what it looks like to me. Oh. Oh, come on. I'm working in a bit of the dark here. What's going on with this? Let's try this one. There's going to be another boom here. There we are. Any minute. Okay. Here comes Peanut. Okay, I think we got it. Okay, we peaked that. Peanut, this is an exciting moment here. I can't really stop. Now we're going to kind of grab the other slug, which for some reason is having an effect, which really got me thoroughly floored. Oh, the coil is moving. That's it there. Okay. We got that done. How are we going to know? Well, one way we can know, I do have some experience with this signal generator. So we set this dial here. This is a, let's say, moderately strong signal that should make the radio operate properly. We're still on the IF though. Not really a too valid of a test, but let's find out what happens anyway. Okay, so that means this thing's receiving that IF frequency. The volume is a little too low to hear it. Okay, that's full volume now. It's definitely better. Oh, Peanut, just hang on a sec. Because we want to... Okay, I gotta stop. Again, he's crying. Peanut, come on. Introducing Peanut, the Wonder Cat. What are you doing here? What are you looking for? Is it food? Often I think, oh, he wants to spend time with me, but then it turns out it's just food he wants. Just food. I'll have to go see. I'll just leave this here and let's go. Let's go, Peanut. Okay, we're gonna switch off from the signal generator. Oh, this guy sounds like he's ready to receive. We have no antenna. Listen. That's interesting. Oh, what the heck? Well, that's the flappy speaker going. What happened? Oh, what happened? Something happened behind. I can't see. Going on? A lot of weird things go on in these. I have to think of that. What? So what is it? Something on my bench that's doing that? What could be doing that? meter connection? Clip lead's a little loose there. Well, I don't know. Got it. Explain me that. Oh, for crying out loud. Hey, then the radio comes back to life after that. Yeah, I wouldn't recommend doing stuff like this. You know, look at that. What is happening? Is this a bad clip lead? Once again, the radio is taken over. What about my plans? What about what I want to do? If I hit it, everybody's going to jump. Me especially. Just this long wire on here? So this is acting like a strong antenna, or like an antenna. So what if I just shorten things up? So you can't see the meter right now, but it's going up a little bit. I would like to use a clip lead for that, though. I don't want to. Let's try it again. Such mysteries abound. Come on, who's fooling around here? Well, I did it. Well, oh, for crying out loud. I didn't even touch anything that time. Very good. A lot of things are not very good. A lot of things are not very good about this radio. A lot of things. Wow. Just what a dilapidated guy this is. Well, let's carry on with what I plan to do. Hook it up to an antenna, see what happens. Hook it up to an antenna. Okay, first, just the... Come on, I just went quiet. Careful now. What is going on? Something to do with the coil? Here I am. Nah, 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 nah. That's what this radio's doing to me right now. Well, I don't know what it is. I heard something there. Okay, carrying on with what I'm trying to do. I'm going to hook up the antenna. A little bit of volume. You can see what's going to happen here. Radios don't work well without antennas. Okay, ground not connected. Loads of volume. Let's see if we can get that some stations. There's a station there. Okay, gibberish on top of it. Worth noting what this meter is doing. 15 volt scale. It's up around 9 volts right now. There. The only hope is in this area. Okay, we're going to put the ground on. With the antenna. Let's see what we get. Turn it up. Close to full now. That's the French radio station. This is the one I use to kind of discover if the radio's doing good or not. The crappy sound could be because of the crappy speaker. It's just blowing with holes all over the place. It could even be a loss of volume from that, I guess. Volume. So where are we on this? Okay, so that's 50% up. So we're close to, we're at the top. Well, there's other alignment issues. It's getting louder. Yeah, it just takes some time. Oh, I'm gonna get a copy. Almost certainly I got a copyright hit from playing some music too long there without realizing it. So that's, if there's an edit in the video, that's what it is. I will go down, just try to pick up something else. Full volume. Okay, let's give shortwave a chance here. Now, is there a local oscillator? Full volume. I'm going to remove the ground here. Terrible interference. So this is behaving as if there's no local oscillator. Didn't I find wiggling this was what? The reason I can say that is the sound from the speaker doesn't change. And that's why I think there's no local oscillator. The other shortwave band sounds exactly the same. I'm guessing that ticking is getting into the radio the same way I was shooting the IF frequency into the antenna. It's coming through the IF. This noise is actually at 455, but I don't know. I don't know what it is. I don't know where it comes from. Just know it's here every morning in my shop, making that ticking sound. Okay, I gotta stop and think about things a little bit. Not sure what to try next with this radio. Well, I can put the ground on here. I should really do that. Okay. Goodbye to that sound. Volume's full. I'm looking for any evidence of reception. Nothing. Ooh. To be sure, I gotta fire a signal generator signal into the radio. Or look at it with the SDR. I got the signal generator sitting right here, so let's use that. It's sitting right here. I've got it operating right here. Okay, ground on. And the signal to the antenna. Okay, we'll go on. We're on the top band, so this would be like 15.2 or something like that. Can this thing receive 15.2? 15, fairly strong signal. Volume is full. Not a thing. Not a thing. Let's get it to work. So no local oscillator. Or local oscillator so far off it's unbelievable. No, we would still hear the tuning effect. There's nothing. There's nothing. Jim, nothing there. There's nothing there. I thought I resolved that. I thought we learned it was just the switch. Okay, got to put on the SDR radio and look for the local oscillator once again. Okay, I have a pickup coil jammed in the radio. We're still up on 15 megahertz, so we'll take this up in that area. 15 megahertz. Now we look. Well, I don't think I see a local oscillator anywhere. I'll tune the radio a little bit and see if anything moves. Nothing's moving around. Okay, I'm going to work the 15.5. I'm going to work the band switch. Let's see. Oh my gosh. And my coil just, my pickup coil just fell on the floor here. Let me put it back in. Don't fall out this time. Just do a little strain relief thing here. Okay, now there's a whopper of a okay, and so I still have the antenna hooked up. The radio's still operating. Turn it up. It is turned up. And we'll tune. So we're at the high end of the band. I'm now going to tune up band and see the local oscillator going down. So I don't think that's the real oscillator. It is a whopper of a signal. I think it's a fake. I think the real one. Didn't I discover it down here somewhere? Like maybe here? Wasn't it around 8 or something crazy like that? Okay, tune up. This one goes up. How am I going to know which one of these are real? So the little ones that are shooting around, like the ones that are just meeting up and crossing over each other as I tune back and forth, those are artifacts of the SDR, and it could be because I've overloaded the SDR. One way to find out if this is real is to try to tune in this signal, not with the SDR, but with a regular radio. Let me just fiddle with the band switch some more. Oh my gosh. Well, yeah, see, look at that. Just moving the switch a little wee bit. Oh, it is jumping frequencies. And then this is on the other shortwave band, which is down around 9 megahertz. What are these signals doing up here? We gotta figure out which one of these is real. That's what has to happen. Okay, so I tune the radio. It's going in the right direction. Let's find out. The only way to find out is to try to tune it in. I'm going to use this radio here. And we're looking for 13, about 13,550, something like that. 13,550. Well, it's easier to move this. There it is, right there. That's 13,540 on my radio, and on here 13,540. So okay, so that's a real signal. What's it doing there? It's a mile out from where it should be. So could well be, and I thought about this when I did this move some time ago, when I replaced the there's a temperature sensitive capacitor in here. When I replaced it, I just stuck in one capacitor. It's a little hard to see, but it's down there. And I just put in a close size. I probably put in the wrong size. That's my finger doing that, was it? Yeah. I'm tuning the radio with the finger. So I realized that, well, I may have to change the size of this to bring the local oscillator into the right range. And that's probably the problem. I probably have to put a little more capacitance in there. I think it was low, if I remember right. Stick a little more in there and the local oscillator will move up. Now, just because the local oscillator is off doesn't mean the radio shouldn't receive stuff. It should be receiving stuff. Right now, if we move this, watching the SDR, we'll move it right on to 13,500. So a signal either side of that by 450 kilohertz. So something right around 13 and something right around 14, and we should hear it. We should hear it. 13 and 14. Here's something. Let's put this around 14 first. Make sure the radio's turned up. Yeah, it's full blast. I didn't hear anything. Maybe it's down here. I didn't hear anything. Give it the works. Just give it the works, Jim. Just beat it up. It's around 13 and up around 14. We hear it again. 14 sounds a lot stronger. It's beating the speaker up. Well, radio's receding, but it's extremely insensitive. Let's just go down one notch here and try again. And if anybody's doubting that, that is because the radio is tuned there. How many more local oscillators are there? How many more? Is it just the one? Or just, yeah, really? Can an oscillator have more than one frequency other than harmonics? I don't think so. I'm probably wrong, but I wouldn't expect so. That is probably way too far to try to adjust using the ordinary tuning adjustments. It's just out of range because of that capacitor. Let's try the next band down. Okay. And you gotta wonder, is this real? What's that at? 13,150. SDR is a great tool, but you gotta know what it does. It does a lot of weird things. 13,150. 13,150. Thought I heard that. So 13,150. So have I got on 13,150? Yeah. So there's nothing there. See? SDR. They lie. Lying. Hey, it's the latest thing. Everybody's doing it. Even the SDR does it. Okay, so we should really find a local oscillator. Did I change bands? Yes. Find it down around the 9 area. Low, I would guess. So it should be sitting up around here, but I bet you it's down here somewhere. I'll bet you that's it there. So this one, very strong signal. 7824. Let's try that. 7824. 7824. Yeah. Wait a minute. I thought I heard that. No. Oh, it's another fake. It's fake. Well, go down lower. It's bad news if it's way down here. Let's see. Then we'll go up. You wouldn't expect it if it's low on one, it'd be low on the other. I don't see it. See, just the one signal. The one great big one. Let's try this again, because maybe I did something wrong. Okay, we'll set this. 7840 is where this signal is. 7840. That's 7524. 7840. 7840. Oh, it's right there. Scratchy, eh? Jumping around. That's not very good. You don't want to hear that when you're tuning the radio. Okay. So 7840. It's supposed to be picking up 9.1 to 9.4 or something like that. 400, half a million kilohertz away. No, this is not. No. I think it's the capacitor. Because there's a number of things that have to align, there's a good chance that with the local oscillator way off, even when I feed in the appropriate signal here for the radio to pick up based on its incorrect local oscillator, it's not very loud. And that's because other alignment issues, RF alignment issues, it's way off. It's just way off, so they're weak. So the other alignment issues are weakening the radio. That's what I think. I think we have to do a complete alignment. So I've done the IF side of things. We've got to do the rest of it. And that's the only way to know. Maybe the radio's working beautifully. It's just out of alignment. That's what I'm hoping, in fact. So I think I'm done for today. Tomorrow we'll complete the alignment and make a judgment about this radio. I may have to rejig the capacitor there to move the local oscillator around. Great. Okay, well, thanks a lot for watching, and that's it for today. See ya.